Let's talk about naming our alkenes using IUPAC system. Now, naming your alkenes is similar to how you would name your alkanes, right? The difference is this time around we have a carbon-carbon double bond, and I like to say that the carbon-carbon double bond rules, right? This is what I mean by that. When you number your longest chain of carbons, your parent chain, the double bond, the carbon-carbon double bond must be included in your longest chain of carbons. That's one. Two, you number your longest chain of carbons from the end that gives the double bond the lowest set of numbers, right? So whether it's a straight chain or if you have a substituent, don't number to give the substituent the lower number. The double bond rules. You number so that the double bond has the lower set of numbers. Let's talk about it. Let's look at straight chain first. So let's look at two straight chain alkenes and let's talk about how you would name your your straight chains. All right. So first thing, find your longest chain, of course. So one, two, three, four, five carbons, right? You also need to locate where the double bond is. Your double bond is between carbon one and carbon two. Take the lower of the two numbers where the double bond is. So the double bond is between carbon one, carbon two, pick the lower number, right? So this molecule would actually be, you have to locate the double bond. So the double bond is at one, right? Five carbons in your longest chain, one pentene. Notice the name ends in E and E. Just like how your alkanes end in A and E, your alkenes end in E and E. So this is one pentene. You might also see pent, one E, and that's also correct. Notice we could not number our carbon chain from the right. Always remember, you either number right, left, left, right. Okay. So I'm already showing how to number from your left, my left to your right, right? And if you number in the opposite direction, this would be one, that would be two, three, four, five. So with blue, the double bond is between carbon four and carbon five, which is a no, right? Since with yellow, it's at one, two. Cool. You get that. But hey, what if the double bond is in the middle of the molecule? Is the same concept. Chemistry is all about concept. It doesn't matter what structure I give you, it'll still be okay. You just need to play around with how you number. If, for this particular example, let's put in our numbers. 1, 2, 3, 4, 5, 6. So with blue. With yellow, my double bond is between 3, 4, right? Your double bond is between carbon 3 and carbon 4. We pick number 3. If I number in the opposite direction, it doesn't matter this time around, it's still between 3, 4. So whether I had left blue or yellow here, we would have been okay. So number left, right, right, left this time around didn't make a difference. So our double bond, when you write your name, you must locate the double bond. So the double bond is between carbon 3 and 4. So we pick the lower number, which is 3. 6 carbons in my longest chain. 1, 2, 3, 4, 5, 6. So it's hex, and then it's an alkene, so it's hexene. So you should know how to name your straight chain alkenes. Find the longest chain of carbon, right? Carbons, and you number left, right, right, left to see which direction gives you the lower set of numbers. I use line angle a lot. I said, okay, let's do a structural. Won't make, I mean, if you can do line angle, you should be able to do structural. So this is a branch chain alkene, right? And remember, one of the first things I told you, when you have your branch chain alkene, you must number in the direction, right? That gives the double bond the lower set of numbers, not your substituent. That's for alkanes. We have alkenes. Remember the double bond rules, okay? So let's work on this one. So if I start numbering 1, 2, 3, 4, 5, 6. With yellow, my double bond is between 1, 2, and my substituent is on 4. Cool. What if we number in the opposite direction? 1, 2, 3, 4, 5, 6. Blue is looking crazy, right? So for blue, your double bond is all the way 5, 6, right? Your substituent is on a lower number, but the substituent don't rule here, okay? Don't forget that. So we would number using the yellow numbers and not the blue numbers. So you number so that the double bond gets the lowest number, not the substituent, okay? So to name this, of course, you list your substituent. Your substituent is methyl. So it's on carbon 4. 4-methyl, right? And if you're in alkenes right now, it means you know how to name alkyl groups, etc. We have 6 carbons in the longest chain here. So it's hex, right? But you must locate where the double bond is. Since the double bond is between 1, 2, the lower number between 1 and 2 is 1. You don't have to put the 1, right? If you don't put the 1, it's implied that the double bond is between 1 and 2. So 4-methyl, 1-hexene. All right, let's look at something that is a little bit more tricky. Let's look at this structure. So this particular structure, right? Let's find the longest chain of carbons in this structure. So my longest chain of carbons, 1, 2, 3, 4, 5, 6. That's the longest chain of carbons. If you do 1, 2, 3, 4, 5, that is not, 5 is not greater than 6. Let me put that in. So 1, 2, 3, 4, 5. Okay, that's the second longest chain in the molecule, okay? So with red, oh yeah, I have 6 carbons, right? But what did we say? Your longest chain of carbons must include the double bond. So if you look at red numbers here, this longest chain of carbon excludes the double bond, right? Let me take these out so you can see what I'm talking about. See, red is not checking for, it's not checking. It's not checking for the double bond. It doesn't include it. So red is a no-go. That's not your longest chain of carbons in your alkene. Your longest chain of carbons must include the double bond. Okay? So let us find our longest chain of carbons that include the double bond. It's here. 1, 2, 3, 4, 5. Right? And of course, my yellow numbers are correct. If you number in the opposite direction, you would be satisfying, you'll be satisfying the substituent having the lower number, which is not the rule, okay, for your alkenes. So the substituent would be on 2, right? With your blue numbers, methyl would be on 2, your ethyl would be on 4, but look at where your double bond is. Your double bond is 4, 5, so it's a no. With yellow, your double bond is 1, 2, right? You can't get any better than that. And yes, your substituents are wherever they are. Key is you number so the double bond gets. You number from the direction that gives the double bond the lower set of numbers. So it's yellow we're going with and not blue, because blue places double bond 4, 5. So now we can name this. On carbon number 2, I have an ethyl group, right? And on carbon 4, I have a methyl group. Same rule apply as with your alkanes, right? You list them in alphabetical order. So it's going to be 2-ethyl, just like you did with your alkane. You list after you found your longest chain with the double bond having the lowest number, you now list your substituents in alphabetical order, just like your alkanes. So this is going to be 4-methyl. Your double bond is between carbon 1 and 2. 1, 1, and I have 5 carbons in my longest chain, pentene. So the rules for naming your alkenes are very similar to the ones to name your alkanes when it comes to order of substituents, substituents, etc., right? So the big difference, so clearly you list the substituents alphabetical order like you did with your alkane. But remember the differences when you're naming your alkenes. Double bond rule. Number from the direction, give the double bond lowest number, right? And if you have substituents, you still number from the direction that gives the double bond the lowest number, then you list the substituents in alphabetical order. I like to say, which is true, the carbon-carbon double bond rules.